Hello there, my name is Jayden Shutt. I'm a general technologist. I typically work within data center infrastructure and cloud computing. This video is about how to virtually and efficiently bring up an OpenStack lab environment. The best way to learn about OpenStack is to actually create it, install it, and play with it. So basically, we're going to get started. You're going to need a hypervisor of some sort. I am using VMware Fusion on a Mac OS with i7 processors, virtualization obviously enabled. Within that, I've created a VM that I'm able to pass virtualization into. Here in processors and memory under advanced options, you can see I'm enabling hypervisor applications in this virtual machine. I've assigned quite a bit of RAM to this box for a Linux server, as well as 3 processors of the 4 I have available, just to be able to speed along the whole demonstration that I'm creating for you. So basically, let's go ahead and start this guy up while we wait, and let's review what's been configured. So this is a base CentOS 7 installation where I've configured static networking. This is, as the name indicates, this is a bridged connection on the network adapter that allows this VM to talk directly as if it was a device on my wireless network. So let me log in as root and show you where I've done these configurations, so that way if you're not completely familiar with Linux, you can create them or configure this yourself. So we're on a VI etc sysconfig network scripts. There's a dash in there, and there ifconfig dash. If you tab a couple times, you can see the network devices. The ENO is the wireless adapter I've assigned to this box. In CentOS 7, on boot on the bottom. Here, let me get my mouse here. On boot on the bottom is always set to yes. In previous CentOS versions, it's set to no, so you're going to have to configure that to yes. You can see that the boot proto is not DHCP. I've set it to static. I've assigned the IP address, the subnet, and the gateway, along with the quad infinite 8.8.8.8 Google DNS server as DNS1. I've really done no other configuration, left everything here because I'm lazy, didn't clean it up, whatever. There's something else to note as part of CentOS, that the sudoers file, let's see sudoers, and then I'm going to make note of this in a second. The sudoers file has a pre-configured group called wheel that is allowed to provide sudoer access to users that belong to this group. So %wheel, which actually is just wheel, is the group, is very important as part of this demonstration. And if you're using the same version of CentOS, and at the time of this video, it is the latest, CentOS 7, which is Red Hat Enterprise Linux, right? Basically, wheel is the great group to add everything to. So here I am, I'm on this VM, we've seen the static IP and everything else. So let's go ahead and start by creating a stack user. The reason we create a stack user is because a lot of distributions of OpenStack will not install under root. They do this as a way to protect from harming the OS or doing anything wrong or providing too much power that is required to install OpenStack. So basically, first thing we're going to do, let's go ahead and create a stack user. So I'm just going to do add user, and I'm going to do stack, and there's -G, capital G there, wheel for that wheel thing that we just saw in sudoers. Okay, boom, done. We're also going to need assign stack a password, as that wheel group that's by default does require a password. If you see right here, let me show you, right underneath that, if I were to uncomment this, no password would be required for anybody in the group wheel. But you know what? Why change things? So basically, we're password wheel. I'm sorry, password stack, and we're going to make the password horrible, which we'll just call the password stack again. Do not ever put this in a production environment. This is purely for a lab that runs on your computer that you can play with. Very simple. So stack and stack, very cool. And once we su to stack, I want to note that you can no longer ls on the root directory. You don't have that access, right? You have the cd home stack, which is where in CentOS 7 the home stack folder is, but that doesn't matter under here. Let's go ahead and SSH into this guy. I'm tired of typing through a console. The green's a little easier on my eyes, even though I have a huge flaming background here. The green terminal just makes me happier, so we'll just do that. Alright, so SSH root, yeah, we'll go to root. Root at 192.168.1.71 was the IP address, and my password for root, which I'm not going to say on video. And then we'll su to stack, and obviously, as I said, stack doesn't have access to the root folder, so we're going to go ahead and go to home/stack. Alright, the next thing we need to do is we need to install what's called the RDO Fedora people repositories. To do that, you got to run sudo because you're under stack user right now. And you sudo yum install -y, so you don't have to hit y a million times, https://rdo.fedorapeople.org, right? And then /rdo-release.rpm. So basically this should install it. Password is a stack. Remember, we added that. It should look for it, and if I typed everything properly, it should install it. Yay, it's installed. Okay, so now we've got the repositories added to our machine here. We need to install the OpenStack packstack, which is supplied through those repositories. So do that, sudo yum install -y, because you don't want to hit y a million times. OpenStack-packstack. Now this is going to take a few minutes, so we'll go ahead and look at a diagram of OpenStack to get a better understanding of it while this kicks off. I'm just going to watch this for a moment. Yep, looks like it's going well, so, or at least it looks, yeah, phenomenal. So let's go ahead, let's bring up this picture. This is OpenStack. This is actually a pretty well designed diagram to show OpenStack, and most of the features which actually we'll be installing right now. Basically, you have the Horizon dashboard on the front end, which is the main thing that people connect to be able to spin up instances or configure networks or whatever. And then this, through APIs, talks to the various services. You have an image service. Think of this like a Pixie boot that will bring a virtual machine up that is sitting there with no OS, no CD drive or anything, just sitting there listening on the network trying to get onto Pixie. We have the Swift proxy. This is an object storage API where you can store all sorts of stuff, files, whatever, just random stuff. It's actually pretty cool. We have Nova, which this is the main kind of API for the virtualization layer. The great thing about Nova that I like to make note of, and it really doesn't show in this diagram, that you can use a lot of different hypervisors. You can use Microsoft's Hyper-V, right? You could use the ESXi by VMware. You could use KVM, which is actually, I think, one of the better ones. And then, at least for the OpenStack uses, you can also use QEMU, which is actually what's installed by default. It's a slower virtualization, but it's great for our lab environment, just for understanding what OpenStack is. We have Sender, which is an API for storage, where it connects to all sorts of kind of block storage stuff and serves that up. We also have Neutron, which is all networking. Like it's like virtual routing, virtual load balancers, whatever. So Neutron handles all of that. And then you have Keystone, and Keystone's actually pretty important for everything to work properly. Keystone is like a domain controller if you're coming from the Microsoft world for all this stuff. But it actually has nothing to do with Microsoft whatsoever. It's just just kind of an authentication service for everything. I don't actually remember the two. I think it's authn and authz or something like that. But not that those mean a whole lot to you, but basically it's just token and cataloging and authentication services for all these various components, including users. There's a lot of stuff you could add to OpenStack to expand its capabilities, and all these can run on one box, which is what we're doing virtually. So kind of like Inception, if I dare make that reference, we're creating a virtual machine that's going to be able to create virtual machines within itself. It's going to be pretty neat. So the default amount of storage space I've assigned this thing is only 20 gigs, and it's not a whole lot, but for this lab and for spinning up some real basic stuff, it's going to be great for the demo. It looks like our command is finished, so the next thing, now that we've installed the OpenStack packstack, which is a collection of like Puppet scripts and binaries and such that allow us to install things, we're going to actually type packstack under the stack user -- all in one. There's a lot. Actually, this is great about this RDO Fedora people stuff, is that you can use packstack and install specific components on systems, right, and very easily expand OpenStack infrastructure, like your compute infrastructure under Nova or anything you want. But for now, we're going to just do all in one, so we'll just let that run. And this is going to take a little bit. Oh, got to put the root password. Note it says root. Yes, we will do that. So it's setting up the SSH keys. While this is going to take a few minutes, I want to talk about a lot of the experiences I've had with various OpenStack installers. I've used DevStack for a little while, and if you're a Linux junkie, you can get past a lot of the hang-ups that DevStack has to get it configured on your system. And this is interesting. DevStack actually uses Chef and Spawn Chef scripts to be able to configure itself in a all-in-one kind of spin it up, temporary to be able to play with APIs for developers. But it uses Chef to configure all that, and I've noticed a lot of very odd behavior under various CentOS versions. Basically, it chokes a little bit. And maybe I need to use Ubuntu with DevStack to make it work better. But you have to kind of help it along. And if you're not a Linux junkie, you don't really understand everything about Linux, you're going to struggle with that a bit. And which is kind of why I did this video, because I went through a lot of the various OpenStack installs and like Crowbar, for example. And actually, Crowbar is super cool. But it gets complex in places where you start, and it's just unnecessary for someone just trying to learn it. And here you can see that it's starting to apply Puppet modules. By the way, if anybody isn't familiar with Chef or Puppet, they can run without a server, so they can run locally. Basically, what this pack stack is doing is it spawned these custom Puppet scripts right here. You can see with my IP address that I believe it's just spawned for, inject IP addresses and passwords or usernames or something into these scripts to allow them to function for this system. Very, very nice and clean. But with Chef, it struggled a lot, and Chef ran off, and it took a little longer than I wanted it to configure DevStack. And that just may be the Chef scripts that are on there. As I understand, Chef is a pretty neat tool, and it is a bit of on the engineering side. Like a lot of it's written in raw Ruby and so forth. But I like Puppet for its YAML scripts. It's just very clean. You describe the system, and then it looks like they use PackStack to be able to pre-configure the scripts a little bit just to make it apply. So right now it's just watching and checking the Puppet scripts, making sure that they all are applying in certain orders and so forth as it goes through this. Alright, it looks like we're back. I stepped away for a few extra minutes just to give this time to install. It looks like it's all completed and happy. So basically what we'll do here is review what's being said on the screen. Note this home stack, pack stack answers. That's going to be kind of important. And here it's mentioning the 192.168.171 dashboard. So let's bring up a browser right here. Let's type 192.168.1.71/dashboard. Let's see what that looks like. And it's asking me for a login. Now there are two logins by default by the RDO Fedora People PackStack installer. I'll show you where to get those. Those are, what's our parent working directory here? You can see there's a Keystone admin, VI Keystone, Jetstone, Keystone RC_admin, right? Permission denied. Sudo, yeah, or sudo cat, even better. All right, there's a password by default in here. Let's grab that, Command C. So let's log in as admin and Command V demo. I'm sorry, Command V paste and then go in here, sign in. Oh, maybe I copied that improperly. Request aborted. So angry. All right, here we are. So I'm not exactly sure. I think I hit it like enter twice or something, freaked it out. So basically we're under the admin interface. This is OpenStack running under that virtual machine. We have compute, and we basically have instances inside here. Right now we don't have any instances. We have our volumes. We shouldn't have any volumes either because we haven't assigned any volumes to instances. We have our images. This is by default provided by the RDO Fedora people. It's a very tiny Linux instance. It's going to be great for the demo. Just to understand what OpenStack is. We have access and security, which is handled by security groups. Under here, if we go to users, we can see what we have here. We have a demo user. We also have a password. We should change some of this stuff. Like, let's go into admin. Let's just edit the admin user and change the password to admin or something. Admin. Update user. All right, now the password's changed. Admin. Now I don't have that horribly hashed password. And then for under our users, let's go ahead and update demo. Let me do this here. Demo, and the password would be demo. That's that way we don't have to overly, try to copy and paste passwords out of files that are in the home stack folder. So basically, compute instances. We can create an instance as simple as going to launch instance and filling out this questionnaire. So Nova, obviously, it's kind of the default. We haven't configured anything else. We'll call this my test instance, right? Just for something. There are flavors. This is sizes set. If you set them, you can see their update over here. This is configured under this admin section. We'll review where that's at real quick. I'm only creating one, and then you know what? We'll go ahead and boot from image and create a new volume. And this will add something under that volume. That's our image. Well, 1 gig's fine. Launch. And so basically, as you kind of see, OpenStack is like a good private cloud version of like what AWS would be, except this is great to allow engineers to spin up their own environments and their own anything they need. And within the admin, you can kind of set billing, or you could set how much they're allowed to be allocated per project under identity. So you should have some projects in here. We have the demo project. And if we look, actually, I'm sorry. If we look in here under edit project, we'll be able to set some quotas like, hey, this is how many VMs they're allowed, this is how much stuff, how many virtual CPUs. Really limit the project. Say, hey, engineering, you're doing a project, this is how long, or this is how much you can have in anything. And it's pretty cool. They can create 10 routers. They can really just go and create their own virtual environment under here. Very handy, very useful for system engineers and system administrators to be able to enable engineers while, not making lives crazy. So here we are. We got their host name here. It shows our QEMU emulator for our hypervisor. As you add hypervisors and install them, they'll show up in this list. And that way you could have one OS that's like Hyper-V, one OS that's KVM. You got QEMU if you want to use it. Keep in mind I mentioned QEMU is known for being slow and not feature rich, but it's good for what we're doing. It can also still do snapshots and restores and stuff, so it's kind of nice. You got your images. This is our default image. When it says create image, basically if you go to your, based on whatever hypervisor you have, if you create an image for Windows or Linux or whatever you got to do, basically you can pre-configure it, install the drivers you need, and you can go to create image and upload it here. It's kind of useful right through the GUI. It makes life really nice. You got your routers. We have our default router configured. Nothing too fancy. Has a couple of interfaces, neither of which are my outside interface. This one's down by default. You just start playing in here and configuring things, finding out how to network inside and outside. There's a lot of tutorials on the internet on how to do that. And so based upon your environment, this is what you can do. Basically, you have your flavors. This is what I was mentioning, the sizes. You got your virtual CPUs and your RAM, root disks, everything. Basically, what they can do, when they spin up an instance and how much it costs them. And basically what that instance is allowed. Whoop, clicking on things here. Let's see if my instance is ready yet. Oh, look, it's active. And basically you're able to create snapshots. You're able to look at your instance. They got all sorts of stuff. You got your log here, which kind of goes through. And it's basically still booting up here. The instance is online, but it's still booting up. And I don't even think console will work yet. Nope. But anyway, it'll boot up, and this is a quick little console to be able to view the visual of it. And it's still sending this guy. It's still configuring itself. And this is the action log of what you've done on the host. So basically it's pretty easy to view, and this is what OpenStack is. When you log in as a demo user, basically you don't get this whole admin section, and you're kind of limited on what you could do. Here's your network topology. Really, all we have is like one network. Shows you the connection from. This is actually really cool because you can terminate your instance. I don't think console will work yet. No. Still booting, but you can view what everything is, and you can add networks and see how it's all connected. It's very, very neat. And adding a network's pretty point and click and easy to do. So anyway, this is OpenStack. This is how you create your little lab environment and start playing in it. And by default, it already works. Pretty much, we should be able to see the volume we just assigned to that box on my test instance. Right? It's pretty neat. So this is a really pretty GUI for being able to learn a little bit about OpenStack. When you go to command line, there is command line options available for you, as well as JSON APIs or RESTful APIs. So play with it, see what you can do with it, break it, whatever. As long as you have virtualization software that allows you to pass on virtualization into your VMs, you're good to go. I hope this video was useful to you, and have fun. Thanks. Bye.